Section 3.2, Part 2, Measures of Dispersion. Lesson objectives. We learned 3 and Section 3.2, Part 1. In this video, we're going to do lesson objective number 4, use the empirical rule to describe data that are bell-shaped. The empirical rule. If a distribution is roughly bell-shaped, then approximately 68% of the data will lie within one standard deviation of the mean. That is, approximately 68% of the data will lie between the mean minus one standard deviation and the mean plus one standard deviation. Approximately 95% of the data will lie within two standard deviations of the mean. That is, approximately 95% of the data lie between the mean minus two standard deviations and the mean plus two standard deviations. Approximately 99.7% of the data, or just about all the data, will lie within three standard deviations of the mean. That is, approximately 99.7% of the data lie between the mean minus 3 times the standard deviation and the mean plus 3 times the standard deviation. This is known as the 68, 95, and 99.7 rule. Let's look at this rule visually. We have the mean here in the middle, and if we go one standard deviation below and one above, this is going to contain 68% of the data. If we go two standard deviations below the mean and two above the mean, we see that that's 95% of the data, approximately 95% of the data. And if we go three standard deviations below the mean and three standard deviations above the mean, this is going to contain approximately 99.7%, or pretty much all the data. Let's look at an example. The scores for all high school students taking the verbal section of the SAT in a particular year had a mean of 490 and a standard deviation of 100. The distribution of the SAT scores is bell-shaped. What percentage of seniors scored 390 and 590 on this SAT test? The next question. One student scored 790 on this test. How did this student do compared to the rest of the scores? And the last question. A rather exclusive university admits students who are among the highest 16% of scores on this test. What score would a student need on this test to be qualified for admittance to this university? First question. What percentage of seniors scored between 390 and 590? Okay, I think drawing a picture will help here. We put our mean smack dab in the middle. We have 490 here, and we're going to go one standard deviation below. So that would be 390 minus 100, and one above, so that would be 490 plus 100, which is 590. So the first question is 68% according to the empirical rule. 68% of the high school students, the verbal part of the SAT, are going to have scores between 390 and 590. The second question, if a student scores 790 on the SAT, then they are above 99.7% of the data. According to the empirical rule, 99.7% of the SAT scores are between 190 and 790. So this student is scoring better than the top 1%. And the last question, we want to find out what score is going to be in the top 16%. Here in the blue, we know that this section is 68%. Well, then that means this tail plus this tail would be 100% minus 68%, which is 32%. This tail, left tail we call it, plus the right tail equals 32%. Since we want the top percent, we divide this by 2 because this is symmetric. This tail is the same area as this tail, so 32% divided by 2 is 16%. A student would need to score 590 or higher to be in the top 16%. Let's look at a student survey example. Following histogram is the heights of males who took Stats 1 student survey for the early fall 2009 to the late fall 2010. A. Compute the sample mean and sample standard deviation. Round to one decimal place. B. Draw the histogram to verify its bell shape. And C, determine the percentage of males who are within 1 standard deviation of the mean, 2 standard deviations of the mean, and 3 standard deviations of the mean according to the empirical rule. This is the histogram. We can see that the heights for males is approximately bell-shaped, so we can apply the empirical rule. The sample mean rounded to 1 decimal place is 70.8 inches. The standard deviation would be 3.1 inches. So according to the empirical rule, if we take the mean plus and minus 1 standard deviation, we get 67.7 and 73.9. Now that means 68% of the males' heights who took the student survey are between 67.7 inches and 73.9 inches. If we go 2 standard deviations above and below the mean, so that would be 70.8 minus 2 times 3.1 and 78 plus 2 times 3.1, we end up with 64.6 and 77. So 95% of the males' heights are between 64.6 inches and 77 inches. And if we go 3 standard deviations above and below the mean, this is going to be 78.8 minus 9.3 and 78.8 plus 9.3, which produces 61.5 and 80.1. So just about all the data, 99.7% of the heights for males are going to be between 61.5 inches and 80.1 inches. Let's look at a visual. So here we have our histogram. Our mean was 70.8, and if we go 1 standard deviation below and 1 above, this will contain 68% of the data. Between 67.7 and 73.9, 68% of the heights are going to be between these two values. If we go 2 standard deviations above and below, that takes us to 64.6 and 77. So 95% of the heights for males taken the student survey is between 64.6 and 77 inches. And lastly, if we go 3 standard deviations above and below the mean, we end up with 61.5 and 80.1. Now this contains approximately 99.7% of the heights, and this is verified in the picture. So the readings and suggested problems are given. Thanks for watching.